Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry Chapter 8 on Section 4 on formula masses, and we are in Part 8. And we're going to be talking about molecular formulas. So we spent a long time on empirical formulas, but you also need to know about molecular formulas. And good thing this is the last hard thing of the chapter. So for covalent compounds, the molecular compound is more important than the empirical formula. Please write that down. So for example, glucose is C6H12O6. Its empirical formula is CH2O. They are not the same thing. Formaldehyde is what we use to preserve things, so it'll kill you, and glucose is what your body needs every second to be used in the mitochondria to make ATP to have your body work. So, super different. Empirical and molecular formulas are different when it comes to molecular compounds. Okay, so molecular formula is some whole number multiple of the empirical formula. For example, back here, it is 6, a multiple of 6 of its empirical formula. So how do we solve molecular formula problems? Well, first thing you have to do is find the molar mass of the empirical formula. So you find the molar mass of the empirical formula, which, up here it'd be like 12.01 plus 2 times 1.01 plus 16. Second, we find the molar mass of the molecular formula. It's usually given in the problem, so don't flip these two around. The molar mass of the molecular formula is usually given in the problem. And then third, you divide the molecular mass by the empirical molar mass, and you use this equation, ratio equals molecular molar mass over empirical molar mass. So this should give you some multiple. If your answer is a decimal less than 1, you did it wrong. You flipped them around. So make sure you do that. Then they should be close to a whole number, and round your ratio to the nearest whole number. And multiply all the subscripts in the empirical formula by this whole number and write the molecular formula. 6. If you needed to, you can multiply all subscripts by 2 to get whole numbers. So like if you get 1 and 1.5, you could multiply it all by 2, and you'd have 2 and 3. Okay, here we go. Determine the molecular formula of a compound with an empirical formula of CH and a molar mass of 78.11 grams. Okay, hopefully you have written the problem down, so let's do that. Your first step is to find the molar mass of the empirical formula. So we have, it says a molar mass of 78.11. They already did it for us. No, the molar mass of the molecule is often found in the problem. We should find the molar mass of the empirical formula. So we see that the empirical formula is CH. So we're going to find the molar mass of the empirical formula, and since it's a multi-step problem, I won't make you show all your work. So the empirical molar mass, but you do need to label things and keep it organized. So C, well, that would be 1 carbon would be 12.01, and 1 hydrogen would be 1.01. So we should have 13.02 grams. So 12.01, 1.01. Okay. Then the next step, find the molar mass of the molecular formula, usually given in the problem. So, molecular molar mass Well, it is given in the problem. And that is 78.11 grams. Okay. Number 3, use this equation and sub in our numbers. Okay, so our ratio equals our molecular molar mass over our empirical molar mass, and then let's sub in our numbers. And we could even underline these to make them color-coded. So, the ratio equals our molecular molar mass was 78.11 grams over our empirical molar mass was 13.02 grams. And then, when I get those ratios, comes out to 78.11 divided by 13.02 comes out to 5.999. And you see that it is a pure number, it's a ratio because the grams cancel, so we don't have a unit. And then I could easily say, yep, that ratio is going to be 6. We have a ratio of 6. Okay, number 4, we rounded it to the nearest whole number. Multiply all subscripts in the empirical formula by the ratio and write it as a formula. So we have C6H6. Okay, an easy way to double check that is to find the molar mass of this and see if it matches the one in the problem. Okay, so 12.01 times 6 plus 1.01 times 6, 78.12, which is very close to that. All right, let's double check we did all of the problem. Determine the molecular formula of a compound with an empirical formula CH and a molar mass of 78.11. We answered the question and we double checked it. Good job. Okay, we've got another example. Please write this down. A sample of a compound with a molar mass of 34.00 grams is found to consist of 0.44 grams of hydrogen and 6.92 grams of oxygen. Find its molecular formula. Hint, what do you need to calculate first? If you notice, in our first example, it gave us the empirical formula, but it does not give us the empirical formula in this equation. So what do you need to calculate first? It does, however, give us our molecular mass. So you have to ask yourself, once I find the empirical formula, I'm going to start at step 1, find the molar mass of the empirical formula, which you're going to have to calculate, and then find the molar mass of the molecular formula, which is given in the problem, and then divide those to get the ratio, and then multiply that by the subscripts in the empirical formula you found, and that should give you your molecular formula. All right, I'm going to have you work through this, and then we're going to go over it during class. Okay, the last things we're going to talk about are nanotechnology, so make sure you've read page 254 and 255. So, nanotechnology is 1/1,000,000th of a millimeter, super tiny. And you're going to be able to tell me what, have you learned about nanotechnology in medicine? What have you learned about nanotechnology in food? So please write these things down. What about nanotechnology in cosmetics? And finally, we are done with Chapter 8. It always seems impossible until it's done. Good job, everybody.